very good morning friends, and in this video we are going to discuss about how to differentiate the implicit functions. Now what do you mean by the implicit functions? Implicit functions are actually not the direct functions, just like when we write fx y equal to fx and then suppose fx is sine inverse x. This is called explicit function because explicitly y has been given as y is fx and fx is equal to sine inverse x. Implicit functions are that instead of you are having a direct function, you are given a relations like x square plus y square equals a square. This is called the implicit function because y can be expressed as the function of x by proper substitution, and then we can make y as subject. So y becomes under root a square minus x square. So now this one you can differentiate directly. Now you have got something like this. So implicit function are like instead of given a function here directly or explicitly, you will be given a relations between the variables where y can be easily expressed in the form of x, or even if it is not properly expressed, then there will be a good relation between the x and y. This is what the implicit relation or implicit functions means. Now I'll take some examples and I'll try to explain you. Suppose I take the same example. Suppose that question goes like find dy over dx if x square plus y square equal to a square. Then how to do that? We simply write differentiating both sides with respect to x. What does it mean? It simply means attach dy dx on both sides. So dy dx of x square plus y square is dy dx of a square. Now, so this is the sum of the two functions, two terms you can say. So we can write dy dx of x square plus dy dx of y square is dy dx of a square. Now dy dx of x square, this is the function, differentiation of x square is using the same formula. X to the power n is nx to the power n minus 1, like this one is the proper formula. So dy dx of x square will be 2x to the power 2 minus 1, that is 2x. This is just the formula. So here we can have 2x. Same thing you can have like suppose x square can be differentiated as 2x, so y square can also be differentiated to 2y, but if it is with respect to y, this is with respect to x, so we have to change the rule using chain rule method. So you just write d by dy y square and then you just attach dy by dx. So see, dy cancelling each other, we have just dy dx of y square, and now differentiation of constant is 0 because a square is not a variable, it's a constant. So this term d by dy of y square, this becomes 2y, and this dy by dx will remain with it, and this is 0, so this is 2x plus. Then you see, if from here if I write dy by dx equal to, I take this on this side, minus 2x upon 2y, so this is minus x upon y. So dy by dx is minus x upon y. I think I made myself clear, but I will take some more example to prove this. How to find the differential equations, or it is also called differential equation. We will find the differentiation of the implicit functions little more. So I simply use this word implicit functions. Now suppose I have a function x cube plus 3x square y plus 3x y square plus y cube equal to 0, and then I have to find the differentiation of this expression. Then what I have to do, you just write differentiating both sides with respect to x, means as usual dy dx of x cube, 3 is constant, just take it outside, dy dx of x square y plus this 3 is again constant, dy dx of xy square plus dy dx of y cube equal to 0. Now here you see x square y, this is product of two functions. One function is x square and other function is y. Here one function is x, other function is y. So many times we will come across the situation where we have to differentiate a function of y with respect to x. So what I suggest you that I tell you a simple rule, and that can make your life a little more easier. Suppose you know that dy dx of sine x equal to cos x. This is the formula which we have discussed and which you might be knowing till now. Now if I have to find dy dx of sine y, like if I have to differentiate sine y with respect to x, you just write cos y. You just assume that you are differentiating this with respect to y only and write cos y, and then since you attach dy by dx. The question is how and why. So the answer goes like, here I make a chain rule. So I make it d by dy sine y, and then this is dy by dx. Now d by dy of sine y will become cos y, and this dy by dx will remain as it is. So what does it look like? Does it not look like that you have simply differentiated the sine y directly into the cos y and just attached dy by dx? Same thing, like suppose if you have d by dt of cos t, d by dx of cos t. What you have to do? You just write the differentiation of cos t with respect to t, that is minus sine t, and then attach dt by dx. Same way, if you have to find d by dx of y square, you just find the differentiation of y square with respect to y, that is 2y, and then attach dy by dx. I think I have made myself abundantly clear. So I come here and then I see that this one I can differentiate directly. This is 3x square plus 3. This is UV rule, this is product of two functions. So the rule says that first you keep one unchanged. So I keep x square unchanged, then I write dy by dx of y, plus then I write y unchanged, and then d by dx of x square, plus this one. Again this is also the same chain rule. So we write, just keep x constant x, then d by dx of y square, plus then write y square and d by dx of x, plus d by dx of y cube, this one, and then it is 0. Now I just write directly. So this is 3x square plus 3x square. Now this is d by dx of y. This is not d by dx. This is d by dx of y. So d by dx of y, just assume that we are differentiating y with respect to dy. So it becomes 1. So this becomes 1 and then attached dy by dx. So this will become 1 and dy by dx. Again, pay attention. What is differentiation of x? D by dx of x is 1. So same way, d by dx of y is 1, and then you attach dy by dx. Got it? Now same way here we have differentiation of x square, that is 2x, and y as it is, plus this is 3 and then x. Then we have differentiation of y square with respect to x. So what we'll do, we'll write 2y and then attach. So 2y and then attach dy by dx. Plus differentiation of x with respect to x is 1. So this is just y square. Plus again same way, y cube differentiation is 3y square and then attach dy by dx equal to 0. Now in this expression you find there are three terms which contains dy by dx. This one, so keep them together because we have to find dy by dx. We have to make dy by dx as subject. So you write, I take dy by dx common directly. So this is 3x square plus 3x and 2y, this is 6xy plus 3y square from here. And then at the same time these non dy by dx terms, 3x square, 2xy and y square, I just transferring them all on the right hand side, so they will all become negative. So I take negative common and then I write 3x square plus 2xy plus y square. And then what is dy by dx? Put this whole thing down. So this is 3x square plus 6xy plus y square. This is your dy by dx. So now I'll take one more example to give you a proper idea that how this has been achieved. Now suppose I have another explicit function root x plus root y equal to root xy. How will you find the differentiation of this one? Again, without any fear, just write differentiating both sides with respect to x. It means d by dx of root x plus d by dx of root y is d by dxf. You know that the root ab is root a into b, so this is root x into root y. Now first I have to find what is differentiation of root x. So differentiation of root x is actually differentiation of x to the power half, and this is half x to the power half minus 1 using the same formula, that is differentiation of x to the power n is n x to the power n minus 1. So here n is half, so this is half x to the power half minus 1. This will become 1 by 2 x to the power minus half. You can bring it down and this index become positive. So 1 upon 2 x to the power half, this you can write as 1 upon 2 root x. So what is differentiation of root x? 1 upon 2 root x. So now I'll be using the same trick so that my life will become little easier and I'll get the answer little quicker. So I write 1 by 2 root x, just like this, plus same thing. Remember the trick, we have to differentiate root y with respect to x. So you just assume that you are differentiating root y with respect to y. So what will become 1 by 2 root y and then attach dy by dx. Now this is product of two functions. So keep one constant, root x constant. Then you find differentiation of y, that is what? 1 by 2 root y dy by dx, plus keep root y constant, and then differentiation of root x is 1 upon 2 root x. Now keep the dy by dx together. Now every term you see necessarily have half common, half here, half here, half here, half here. So we can take half common and can cancel it without doing anything. And at the same time, so I just try to do that, I take 1 by 2 dy by dx common. At the same time I'm taking common and I'm keeping the things in the proper order. So I'll take this one on this side. So this one as it is 1 by root y. This one comes on this side, becomes root x upon root y equal to this one as it is. Again I'll take half common from this also, 1 by 2 root x, and this one comes on this side, and since half has already been taken common, so it is 1 by root y. Now this half cancel. Then your dy by dx will be dy by dx. I can take little calculation here and I can find this as 1 minus root x upon root y, is taking the LCM, and this one is root y minus root x upon root xy. Now this term will divide this term, and I write here. So dy by dx is root y minus root x upon root xy into this reciprocal this, because this is coming on this side divided, so we know that how to divide this reciprocal and then multiply. So root y over 1 minus root x, this and root y cancel, then what you are getting on the top, you are getting root y minus root x, and down you are getting root x. If I multiply this root x with 1 minus root x into 1 is root x, and then this is minus x. This is the idea of differentiation for the implicit functions. So thank you very much for watching our videos and subscribing. At the same time, in the next video we will do about some more beautiful implicit functions and derivation of implicit functions. So just get ready to watch that video also.